you want to start off?
Me too. Okay. Hey guys, I'm gonna get started now. I know attendance is looking a little sad today, but that's okay. I think it's like a busy prelim week. Do you guys have prelims tomorrow coming up? No, okay. Well, that's good. That's good. I'm glad you guys are here. So today's gonna be a pretty important lecture. So if you remember everything that we talked about this Monday, we're gonna be basically implementing all of that in Swift. So all the network requests that we made and the things that we did in Postman, we're gonna all make that all come to life in Swift and in our actual applications. So for a quick announcement recap, the midpoint was due last night. So as long as you've made a commit to your GitHub repository, we'll be taking a look at that and grading you accordingly on CMS. And if you need feedback or you need help debugging, I'd say I think it's easier to debug over at office hours, but I understand that some of the hours are weird. So feel free to make an ad post to, you can attach your code, you can attach a code snippet, or actually no, we can just look at your repository. So you just make an ad post and we can help you take a look at whatever issues you might be running into. So yeah, just to reiterate, we're looking at the commit history, so you don't actually have to post or submit anything to CMS.
Yep. And I guess keep in mind, we're not really going to be giving you guys feedback unless you guys request it, just so we don't have too many people to look at. So if you guys do want feedback, make sure you guys do make an ad post for that.
Yep, it could be as vague or as specific as you want. So if you have a specific issue, you can post an error message, or if you have a general conceptual problem with getting started with something, you can also post a question for that. Cool. So I guess in the same vein, 8.3 final is due next Tuesday. So that's 6 days from now. So that's where we'll actually ask you to submit your TXT files onto CMS and have you basically run your projects for Rails and test all the functionality we're looking for. Cool. Okay, so for some content recap, this Monday we went over a lot of conceptual stuff when it came to networking. The first of which is a HTTP request and how that consists of a client and server relationship. So remember that a client requests something from the server and a server responds with some sort of information or with some sort of status code as well. So in this lecture and as well in this class, we'll be only looking at GET and POST requests. So if any of you guys have taken the backend course, you might be familiar with more, complex requests. Not necessarily complex, but other ones like delete and patch and etc. But just for the scope of this class, we'll only be looking at GET and POST ones. And if you recall, we used JSON as the data type format to communicate between the front end and the back end, meaning that when we send information to a server or when we get information back from a server, we're sending in JSON format. Okay, and then lastly, we talked, a little maybe much about callbacks, but callbacks are important, if you recall, because we don't want our app to freeze and basically be loading while we're waiting for a network request to complete. So the idea of callbacks is that you have a function that's called at the end of your network request to tell your app to, okay, you can update your table view now, right? Okay, I fetched all these posts and now I can finally update without my app getting stuck. And lastly, we also talked about the protocol of Codable and how we have to conform all of our models to Codable in order to be able to decode and encode to and from JSON. So what that means is that if you don't conform your models to Codable, so whether that's a model for a post that contains a text or image, you have to conform to Codable in order to be able to do networking. Okay, so to start with some conceptual content before we actually go into, the nitty-gritty in terms of coding, we're going to first talk about Alamofire. So in Swift, there's a few ways that you can perform networking requests. The more, how should I phrase this? The more, built into Swift is something called URL session. So URL and then session. And Alamofire essentially is a library that's built on top using URL session that makes the syntax and the whole networking process a lot more intuitive. So technically you can go about adding networking to your project two different ways, but just for the I guess scope of this class, we'll be using Alamofire. And if you're interested in learning how to use your URL session, there is a tab on the course website that talks more about that. Okay, so no more blabbering. Let's talk about like what this actually is, right? So as I mentioned earlier, it's a networking library written in Swift, built on top of URL session. Richie will show you guys later how that looks exactly, but some common use cases, fetching a JSON from the API. So this is like getting a bunch of posts back and then posting some data to an endpoint. This is like if you want to upload a new post, you can use Alamofire to create that post request the same way you would do so in Postman as a client. Downloading an image from URL and authentication with a REST API, which we won't be going to, but may be useful for some of your hack challenge projects. And I guess to incorporate Alamofire into our project, we use something called a NetworkManager class. So this actually isn't like some specific like class in I guess in Swift, but it's actually a class that we define ourselves in order to create all these functions with Alamofire. So you can imagine if we had a bunch of different requests we wanted to make for an app, like I guess we always use Instagram as an example, but Instagram you can like post reels, post a bunch of different things, and also get posts, get reels, etc. So there's like this entire slew of different requests you can make. And if you imagine, if you try to define these requests all in different folders and in different files, like I guess if you try to define a get request every time you need to use it, you end up with a lot of, I guess, first repeat code, because if you're making the same request but just in different places, you'd be writing the same request over and over again. So that's the point of a network manager in our case, where we're basically defining these functions once, creating this sort of shared singleton instance. You don't have to know what singleton means in this case, or I guess for the scope of this class, but just know that when we want to use the network manager, we create a static. You remember what static means? It just means that it's a property of the class and not of an instance of the class. So you can directly call network manager that's shared to basically have an object, I guess, an instance network manager that we can use the functions of. Any questions? It's like kind of a lot of blabbering, but the idea is that we use this shared variable throughout the I guess the rest of our app to access a bunch of networking functions. So you wouldn't be writing a networking function every time you wanted to like fetch all posts. You just have one, I guess, outline of fetching a post, and then every time you want to fetch a post, you would just call share.fetchPost, and that kind of eliminates a lot of repeat code. Cool. So this is just a class. So as you can see, you import Alamofire, and you just find a class called Network Manager. And I think Richie's going to go into actual detail on how to actually do that.
Yep. So today is going to be a very demo-intensive lecture. So I would very highly recommend you guys follow along with the sort of demo that we have here. So if you go out to the course website and go down to Networking 2, we sort of have everything set up here. And don't worry if you can't catch up with the speed I'm going at. You can feel free to check out this branch, or for those of us here already, you can feel free to rewatch the video, because this is sort of like a pretty tricky lecture to understand. Okay, so I guess while you guys are coding that, I'm just going to go over like a brief overview of what we went over yesterday, because today we're going to be sort of building off of that. Okay, so if you guys remember from Postman, or if you guys weren't here for last lecture, so Postman is sort of a tool that allows us to sort of test backend calls. So if you see from last lecture, we sort of have this get roster as well as this post roster here. So we fetch roster, just send it real quick. Hopefully I'll take it on. Okay, so you can see that we sort of have this roster of app dev members, where each member has a name, position, and subteam, all of which are things. So in this lecture, we're sort of going to try to incorporate this backend call, which is currently on Postman. We want to incorporate that into an iOS application that we've developed, so we don't have to sort of use hard-coded data in all of the apps that we're developing. Okay, so I guess if you guys have everything pulled up, let me just make this bigger. Okay, hopefully that's good enough. What's going on here? Oh, oops. Okay, there we go. Okay, so if you guys pull up the sort of demo here, you'll see sort of we have a lot of starter code already. And you see here in the package dependencies, we have Alamofire right here. And then if you do want to sort of import your own packages, so the whole process is sort of done for you for A3 as well as this demo. But if you sort of right click in this left tab section, there's sort of this add package dependencies here. And what you would do is sort of import your package directly here. So right here you can see Alamofire, and that's already imported for us. But usually if you want a package, you would just paste the URL of the GitHub right here, and you would be able to add that package. But currently we already have that done for you, so you don't have to worry about that until possibly the hack challenge. Okay, so without further ado, let me just run our current app. So I guess just to, while that's running, explain what we have. We sort of just have a basic table view setup, and each of these table views represents a member of our team, which has a name, subteam, and position. And we also have this dummy data, which is all entirely hard-coded. So, if someone adds a new member, we won't be able to see it currently because all of our data is only based on dummy data. So we go back to the simulator here. It's still running. Anyway, so yeah, currently it is all hard-coded. Let me just go over the overview of the code a little bit more. And you'll see it's just sort of just a basic table view setup, delegate, everything there. It's been covered in previous lectures, so I won't go into too much detail there. But hopefully this will run so you guys can see what it currently looks like with the dummy data. Sorry, I ran this before and it's still slow. Okay, there you go. So you can see sort of we have a basic table view setup where each cell has the name, the position, as well as the subteam of the members. And this is entirely based off, again, the dummy data here that we have an extension of. So you can see here the data is actually stored right here. But we have it actually stored in the member instance since we don't really want to clutter our view controller too much. So we have an extension to member within the member folder here. And then you can see that dummy data exists right there. Okay, so what we want to do with this now is we want to sort of implement our GET request so we can fetch our member list from the database that we have stored at the URL. So that sort of requires us to write some networking functions, and what Tiffany mentioned earlier about NetworkManager and things like that, we're sort of going to be directly applying today. Okay, so the first thing we want to do is actually get rid of this dummy data right here. So actually we want to keep this sort of variable. We want to set the type as a list of member objects. And instead of setting to dummy data, we want it to be empty because the first time we initialize our app, we always want it to be empty in case we want to fetch something from the backend that has updated data for us. So that's the first change we're going to do. The next one is sort of, let us define a function called, let's say fetch members. That's what you want to call in viewDidLoad here. So let's call it first. So essentially, it's just an empty function stuff at the moment where this is sort of going to be the function that we're going to be calling to sort of fetch the members that we need. Okay, so we're going to start off with sort of creating a groups folder for our network manager. So we're going to call it a new group. And we're going to call it networking. And we're going to create a new file called the network manager. And that'll just be a base Swift file, as you can see here. Okay, and we'll call that network manager, like so. You can see we have this sort of file created that has the foundation imported. So we also want to sort of import Alamofire right here on top of that so we can actually call these networking functions using our package Alamofire. Okay, so once we import that, we can actually now quickly define the class for Network Manager. So keep in mind, this is going to be sort of the hub where we're going to store our networking functions. So let's create a class for that. And okay, so what I'm going to do next here is sort of outside of exactly the scope of the course. You're not really needing to know too much about what this does specifically, but we're going to create a singleton instance of our Network Manager class, which essentially means that we only want one object of Network Manager to exist at a time. Because we don't want multiple managers, we just want one manager that has our stored functions in it. So what we're going to do is define a variable, define a constant called shared, and we want to make that static so we can access it directly through the network manager class. And what we're going to do is actually call the constructor for network manager within itself and sort of have a shared instance of itself within the class. It may seem unusual, but this sort of ensures that we only have one object of the network manager class. And to further sort of specify that, we want to make our initializer private. So what we want to do is define a private initializer. And then we want nothing in it, just so we can never actually create another instance of network manager. So now that we have sort of the network manager set up, we want to start implementing our functions. So as Tiffany mentioned before, network manager is very useful for reusing our network code. So what we want to do is let us define a function called getRoster. That is sort of the get request that we're going to make to the backend that allows us to fetch that roster information from the database that we have before that you can see sort of is stored here in, or displayed here in Postman here. So this is sort of what we want to fetch and we want to obtain in our iOS app itself. So the first thing we want to do is actually get access to this URL endpoint. So what we want to do is, it's not on this current lecture, but if you go back to networking 1 from the previous lecture, you'll see that we have our get request or endpoint request right here. So what we want to do is copy that. And we can define a constant called endpoint as a string to sort of store our endpoint where we're going to make our request. So this is sort of our communication with the backend server is through this URL, and we're fetching as the client the information from our server through the internet. Okay, so once we do that, we can actually now try to sort of define our function. Actually, I forgot one step. So our getRoster function actually, so we want to get roster. So our function should sort of return, I guess, a list of member objects. So if you remember from the first lecture, we sort of specify a return type using that arrow key signature there, and then we can just specify that we want to return a list of members. And then what we want to do now is we can invoke upon this package by calling AF, which is short for Alamofire. And then we can just do AF dot, and you'll see there's something called request. And what we want to put into request is first the endpoint. And the next thing we want to do is sort of what kind of method we want to request. So in this case, if we specify the method, if you type dot, there's going to be a bunch of options. But in this case, because getRoster is a get request, we're going to be using a get method like so. Okay, so now that we have that set up, we're going to sort of need to validate our result. So if you remember from last lecture, when you make a request, you sort of get a response, and that response gives you a message ranging from 100 to 500. So what we want to do is validate that our result is going to be a 200, which means success. Any other thing is either informational or an error, so we don't want that. So as you can see in the specification here, validate it ensures that sort of our result is filtered so that is within the acceptable range of 200. So that ensures that our sort of request is successful, and we'll do information based on that. And the next thing we want to do is sort of decode the response. So we can do that is another dot, and then called response decodable of. Oh, okay. So I don't think that'll, let me just type it out, so just in case you guys don't get that. So of, so the first thing we want to specify is the of, which is sort of what we want to decode into. So if you see here in our member object here, we want to decode whatever we have in our backend to this struct we sort of defined here that represents a member of the team. So if we go back to the network manager, we want to sort of decode into a list of members. And then because we want to specify the type, we actually need to add the dot self. So we specify that we want to decode it of something of the member class itself, not really an instance of it. So that's why we need to specify self. And the next thing we need to do is sort of allow us to decode what we have in JSON format, which is stored in the backend. And we want to decode that JSON string into a usable struct in Swift. So that will require a decoder. So we add this parameter here called decoder. Now we have to sort of specify a decoder. And lucky for us, Swift sort of has one built in, so there's no need to do any complex things with like sort of keys and things like that. So we have our own. So let's define a constant called decoder and set that to something called a JSON decoder. And we can just call that constructor there. And we already automatically have a decoder that allows us to convert from JSON into a Swift struct. And that is sort of what we pass into this variable here. Okay, so if you see that, now, once we have that, there is sort of a last thing that we need to do, and that is sort of implement a completion handler. So if you type in completion handler, it'll sort of give you this stub. And then what you want to do is actually click on this. It's already clicked. You see it's highlighted, and click enter. And that should sort of format it for you to where essentially you can think that the completion handler is sort of called after the request is completed. We'll go into more detail about that later, but for now, what we want to do is call this sort of response. So this is sort of the variable that we're using to represent the response that we get from response decodable. Okay, and you can immediately see that we sort of have this error here called data request requires that member conforms to decodable. So as mentioned in last lecture, we are unable to sort of decode into a struct unless our struct conforms to codable. So what we want to do is actually make sure our member object or struct here actually conforms to the protocol called codable, which allows us to decode and encode to and from JSON. So by specifying your member struct is codable, we're able to sort of convert from JSON and vice versa. Okay, so now if we go back, this error should disappear. Okay, perfect. Okay, so now what we want to do now is, if you see this response object here, it's sort of a custom type. So you show quick help. So you see that it's sort of called AF error, or things like that, data response. So this is sort of a custom type built into Alamofire. So what we want to do is actually there's something within the response called, let's say, a result. So this is the result sort of of our call. So this is either an error or sort of the data that we're requesting. So this is sort of stored in something called an enum, and we didn't really cover too much into this, but there is sort of a textbook chapter on it. Honestly, you don't really need to know too much of the specifics, but essentially, I guess just know how we can sort of decode or an enum using a switch statement. So I guess closely follow the syntax here. So what we want to do is use the keyword switch result. So we're switching on response.result. And within this switch statement, we have multiple cases which are specified in our enum. And again, this is sort of, you can think of this as like a complex if statement. But essentially, we have specified cases within the result enum, and we want to account for each case. So the first case, so we can use the keyword case now. And then to look at any of the cases we have, just type the dot. And then you can see we have sort of two cases we have to account for. We have success and we have failure, just to account for either the request succeeds or the request fails. So let's account for success first. And you can see that we sort of have this list of members here, and we want to sort of specify a constant. Let's call that let members. And then for now, let's just add a break statement here, we'll come back to that later. And then we want to do the same thing for .failure. However, this time you can see that it's an AF error. So let's call a constant, let's call that error. And in the error case, we actually just want to print out that error so we know, something went wrong while we were making that request. So you could just simply make a print statement, and it's always a good idea to specify where this error is coming from. So what we like to do is error in NetworkManager dot, and this function is called getRoster. So we know that if an error does occur and it does get printed to the console, we know that it comes from this. And the error object we defined here actually has its own sort of thing. So we can do error, we can print out the error itself, and there's something called a localized description. And that sort of gives us more information about the specific error that occurred in the case that we sort of have that issue. Okay, so now keep in mind that our getRoster function wants to return a list of members, but so far we haven't returned anything. So we sort of have this error here that we need to return an instance of the method of, a list of members. So since we have access to the members here, we can simply just return members, but keep in mind we have to account for multiple cases. So the success case will return something, but the failure case won't return anything. So what we want to do is actually define a variable up here, and we can call that, let's say, fetched members. Oops. And that's going to be a type, a list of members. And that is going to be an empty list at first. And what we can do here is once we have that success case, we can set fetched members to the members that we get after we complete the request. So essentially we're storing the value that we get from the request into this empty variable that we sort of stored before. Sorry. And then now since fetched members exists outside of the request, we can simply just return fetched members. Okay, perfect. So now we have this sort of function that we define in NetworkManager, and this is sort of separate from our actual app itself. So what we want to do is actually call this function in our original view controller that we have back here. So I'll give you guys a second to finish typing up. We should be fine, hopefully. Okay. So if we go back to our view controller function, view controller here, you'll see that we have this empty function stub called fetch members. So what we want to do is actually, since keep in mind our get members function in our network manager returns a list of members, we want to sort of set our members attribute here that we set as empty to sort of the return statement that we have of the function. So you set members equal to, and then we can directly invoke the class network manager .shared to get that shared instance, and then we can automatically call that getRoster function, which returns a list of members, and thus we are able to store that result into our members variable. And then the last thing we want to do is sort of, because we sort of fetch this information, we now want to update our UI to make sure that all the information is displaying there now. So what we need to do here is we need to invoke the table view, and then we want to reload the data in that table view so we can actually display this newly fetched data that we have. Okay, so now let's try running that and see what happens. Build succeeded. Okay, so it seems like we're running into an issue where none of the members we actually have are displaying. So a good way to sort of debug in Swift is to have a lot of print statements. So what we can do here, let's just print members, see what's going on here since nothing is displaying. And again, I think it should print in the console here, but it seems like members is somehow empty despite the fact that we called this getRoster function from our network manager. And okay, let's delete this print for now. And let's go back into Network Manager and maybe do some debugging there. And let's see, we have fetched members, we set that there. So maybe after the request, we can print out fetched members to see what we have here. And let's run that now. So remember before when we sort of printed this out in the view controller, it was completely empty. And it's still not showing up, but if we print it from the actual network manager, you can sort of see that we actually have all of our members listed out here, and this is sort of all the members that are in the backend. So our request actually succeeded, however, it's still not updating for some reason. So I guess the sneaking suspicion that I have is sort of this is not sort of in sync with this, meaning our return statement could be happening before our request actually finishes. And to actually test that for real, let's sort of print first here. So this code here is actually supposed to complete first, right? Because this sets the fetched members, which we're returning here. And this actually part of the code here should happen second because we only want to return after we actually get that information from Alamofire and that URL we set. So if you run here, it should, what we want the action to be is that we want first to be printed and then second. But if you see here, that's not quite the case. Oh, okay, ignore that. You don't still have to worry about that. That just sometimes happens. But let me just get rid of that for now. No, there's no way to filter that. Type info. Nope. Okay, just ignore those errors for now. But you can see that second was printed first, and then first was printed second. So we actually want the reverse to happen. But for some reason, our request is taking a little bit too long to where our return statement is actually happening first, and then whatever in this code is happening later. So we're actually not returning anything, we're just returning this empty list here. So does anyone sort of know why this is happening? Yep.
Because the request is asynchronous, so it's like on a separate kind of like thread.
Yep, exactly. So because our request takes a long time to sort of process, our UI is unable to sort of respond in time because that is happening asynchronously. So we discussed this last lecture sort of, is our solution to this is something called a callback, or I guess specifically in Swift, it's called a completion handler. So what we want to do here is rather than specifically returning a member, we want to sort of have a function that we pass in that we call upon completion of this getRoster function. So what we can do here is specify a parameter called completion. And we want this to be a function because we're going to be passing in this function, and then we're going to be calling this function after completion of the request, so we can ensure that regardless of what happens, we only call that function when the request is completed, so we don't sort of get that issue with nothing showing up. So to specify that, we want to specify the type as a function, so we want to sort of have this type, which is and this function is not going to return anything because we just want this function to do something. This function is going to be performed once we finish this request. So the type we want is actually to have a member. So this function should take in a list of members, and sort of do something with it after the request is finished. So this is sort of the type we want to specify, to where we have the parameter for a member and we return nothing. And our actual getRoster function should not return anything. Keep in mind, this is a parameter. So our parameter is a function that doesn't return anything, and our getRoster function should actually be the same. So let me get rid of these print statements so we don't see those later. Okay, and you can see that we have completion here, and this is essentially the function that we're calling upon completion of the request. So we can call it as any normal function. So rather than setting fetch members, which doesn't exist anymore, we can directly call completion. And then completion, we want to pass in the members. So like that. So another thing that I forgot to sort of specify is we want this function call to sort of outlive the function around it. So we're calling this completion handler after getRoster is called. However, we want completion to outlive this getRoster function. So what that requires us to do is sort of specify a keyword called @escaping, which allows us to ensure that this function that is passed into the parameters here outlives whatever function that we're calling it from, which is getRoster. Okay, so in the case of failure now. So in the case of success, we're returning the members that we're fetching. And in the case of failure, just for safety reasons, let's just return an empty list. Just so, in the case of failure, we don't actually want anything to display there. Okay, so now if we go back to the view controller, we sort of have a few edits that we want to make to this original fetch members function. So since NetworkManager.getRoster is not actually returning anything, we don't actually need to set members directly to it. What we can actually do is go back here and .shared.getRoster. And you can see that this time we have this parameter called completion that takes in this function that takes in members and returns void. So what we want to do now is sort of specify, I guess, of sorts, an anonymous function that doesn't really have a definition. So if you press enter on this highlighted area here, you'll sort of see that it auto-completes, and you can sort of treat this as the parameter. So we're going to name that members. And this is sort of the function that whatever code we put into this code chunk here is going to be executed after that request is completed. So what we want to do here is actually update whatever we have here. So we have members. So we want to set, but the first thing we want to do is actually, I'm not going to go into too much detail of what this means. And essentially, we're going to make a weak reference to self. So we're using keyword weak and then self. So this sort of ensures that we don't have data leaks. So in large-scale applications, when we have multiple screens, there's always chance of data leaks. So if we have a weak reference to self, this sort of prevents that. I won't really go into too much detail on why, but whenever you do sort of requests like this, it's always good to have a weak reference to self. And because self is now weak, it is optional. Therefore, we have to unwrap it using our guardlet. So again, I won't go into too much detail on why this is important. It'll come out later on, but for now, just make sure that we sort of have this notation here. Wait, what's going on here? Oh, guardlet, my bad. Okay, so now we're unwrapping self, so that's strong. And then what we want to do here is set the attribute members equal to the members we have here. So now we're sort of updating our data to the new members that we're requesting from the backend. And then what we also want to do is sort of reload our data as well at the same time so we actually can get that displayed. And if we run that now, hopefully we'll have our desired result of the roster being printed out. It might take a bit. Okay, perfect. You can see that it took a bit. So after, we opened the app, you saw that this popped up, and then this popped up after, so that's a good sign. This means that we only display the data once we fetch it, so we have no risk of sort of displaying no data, even though there is data. Okay, and like one more small thing before we move on to sort of post requests is that if you see this reload data, we want anything to do with UI to sort of happen on the main thread. So this is sort of going into concurrency, so I won't talk too much about it. We want this to have the highest priority. So how we can do that is specify using a dispatch queue. Again, this is not really important of why this is important, but just remember anytime you want to update UI, you sort of nest it into this block called dispatch queue.main.async. And what we want to do here is sort of call this on the main thread. So we set the highest priority to updating the UI just in case that anything goes wrong. And keep in mind, we also do need to specify self as well because it's contained within the view controller. And we do that, you can see there's no real change to it, but on larger scale applications, this becomes a lot more important because you're prioritizing the UI so that users don't really have any buffering going on when you're loading large data and things like that. Okay, does anyone have any questions before we move on? Okay, perfect. I know that was a lot, and sort of, I'm going to go into less detail about the post request because essentially it's the same exact thing, but this time we actually want to post something to the backend, meaning we're taking data from our app and we're posting it and putting it onto the database that's stored within our URL. So what we want to do in this case is, like, again, you can see we have this sort of function stub already in our view controller called add new member, and that's sort of connected to this button that we have here. So this button, upon clicking it, should allow us to add a member, but right now it's not implemented. So what we want to do now is go back into our network manager, and this time we want to sort of make a post request that allows us to sort of post a member to our roster. So again, we want to define a function, let's call it add to roster. And then this time we want to sort of have a parameter. So in this case, we want to add a member. So let's name a parameter called member, and it should be of type member. And this allows us to sort of input that information. And like before, we sort of want another completion handler so we can ensure that no like funny business happens again. So let me just type that out real quick. And then, so this time our completion handler should only take a member. We want to sort of return a member object rather than a list of members because we're only adding one member in this case. We're not fetching all of them. And then again, we want this to return void. Okay, so now we sort of have this function set up. So where it's essentially the same style as our get roster, except we have this extra parameter called member, and we are sort of having a completion handler where there's only one member rather than a list of them. Okay, so again, we want to use sort of the same endpoint. So keep in mind the endpoint can vary between get and post requests, but just for simplicity of this lecture, they're going to be the same. So what we actually do here is sort of move this outside of the specific function and sort of define it globally, and this decoder as well, because we're also going to need this as well, and define it globally so we don't have to repeat code. So again, we can just directly call the same endpoint that we have here with our post request this time. So again, we're going to invoke Alamofire, and then we want to request. Like before, this time, rather than returning a list of members, we want to return a member. So again, we're going to put in the endpoint here, and then our method this time. Since we are posting to the backend, we're not getting, we want our method to be posts, as you can see here. So this time we're sort of giving data to the backend, so this sort of specifies that we're giving data to the backend rather than getting it. And again, we want to validate as well, just so we get that 200 message rather than any errors. And we want to again use response decodable. And then this time, our of should be whatever we're returning, right? So this time we're only returning a member, because once we post a member, we'll actually get the member that we added back in the backend. So again, we're specifying that we only have one member this time rather than a list. You can see up here we have a list of members. This time it will only be one member. And again, you want to specify the class itself, so you want to use that .self keyword afterwards. Okay, and this time around, we sort of have something different, right? We want to sort of pass in these parameters that we have into the backend itself. So you can see we have our parameter for member here, but we also want to specify it within the Alamofire request so that we're able to sort of give this information to our API. So what we can do is let's define a constant called parameters. And there's something called type parameters, actually. So we're naming something called parameters of type parameter. And that is sort of, you can think of that as like a key value pair that we have. So it's essentially a dictionary. And so that's going to be here. And you can sort of think this as us encoding our struct into JSON. So we're not actually using an encoder for this. We're sort of doing it manually by creating our own JSON here using the parameters class here. And then what we want to do is we have name. And we want that to be the member name. So member.name. So again, we're specifying that name is of the, so the key name is matched with the actual name, which is stored within the member object. We also have subteam, which is member.subteam. And lastly, we have position, which is member.position. So essentially, you keep in mind that our member here is a struct in Swift, and what we're doing here is actually converting that struct manually into a JSON string. So this you can think of as the JSON string that we're going to pass in, which is in the form of a parameters object that is a class in Swift. Okay, so now what is sort of different than our GET request, so within our response decodable of, we actually have something called wait, sorry, what is that? Oh, my bad. Okay, so actually response decodable of is not different. So what we're actually going to be putting this parameters is within our request. So there's something called parameters within our request itself. And we want to do in this case is pass in the parameters that we defined above, like so. Is it? Okay, so, okay, yeah, sorry. I'm really too. Keep in mind the ordering does matter, so you have to put parameters after method. My bad. So you'll see once the colors are correct, that'll be okay. And then we also want to sort of specify an encoding this case. So we want to encode into JSON. So we have another parameter called encoding. And this sort of specifies that we want to sort of encode whatever parameters we have here, which is sort of in the JSON format, into an actual JSON. So what you can actually do is specify the coding itself. So we can use JSON encoding, and then we want to use the default encoding for JSON. So, again, you don't have to really know too much of what this means specifically, but keep in mind that you do need to specify a parameter section as well as an encoding, unlike in the get, which is just the method and the endpoint. Okay, and now we can sort of go back into this response decodable of and sort of input our decoder again, which again, we can just go back up here and use the decoder that we created up here. Okay, so we have decoder and we're passing that to decoder. And again, because this is a request, the request sort of itself has a completion handler that handles the response. So we type in completion handler and then we hit enter again on that sort of stub. We can just enter response like so again, sort of mimicking the same structure we have here. And since this is a Alamofire request, we want to switch it again using a switch statement. Result. And then again, we have two cases because this is a request. So we have case success and we have case failure. So again, this case, we're only having a member, so we can let member. In this case, since this is a post request, our result does not really matter, but some cases you sort of want to get the member you're adding. So, you can update the UI. So let's say you're sending a message. You still want to update whatever UI you have with the message you sent yourself. So that's why we have this response with member, but we can just, again, call our completion handler and return that member. And with failure, we can let error. And again, we want to print that error out. So we can print error in NetworkManager. In this case, our error would theoretically happen and add to roster. And then we actually want to input that error and print out its localized description like so. Okay, so you can see now that we sort of have this request completed. So you can see that the structure is very similar to the get roster, except keep in mind we have to specify an actual parameter up here, as well as create our JSON encoding like so down here and down here. Okay, so now that we actually have this function, we can now invoke it in our view controller class here. And what we want to do is call that function within our add new member function, which is tied to the button that we have up there. So usually what you want to do is, take user inputted information and sort of create a new member based on that. But just for the sake of time and simplicity, we're just going to create a default member with dummy data, sort of. And let's say we're going to use Vin. It's going to be iOS and iOS lead. Okay, so we're adding sort of this. So this is normally, like I said before, we would use like text fields and stuff to sort of obtain this information from the user. But just for simplicity's sake here, we're only going to create sort of this hard-coded newbie here, or I guess member. And then, yep, so now that we have that, we want to, again, like we did here, call NetworkManager and grab that shared instance. And this time we want to add to the roster. And you can see we actually input our member here. And then our completion handler, we could again can press enter, and then that'll sort of complete that for us with an anonymous function. And this time we want to print that member. And this time we don't really need anything, so you would just do something. Since in this case we're not really doing anything with our response, we just want to add to that roster. Okay. Just so we have sort of a difference to that, we're going to add some text to that because there's already a Vin in the database, I believe. Okay, so if we run now, hopefully when we click this button up here, we'll be able to add Vin to the actual roster itself. Okay, so we have the roster loaded in, and you can see that, Vin that we typed in was not there. This is not the same. This was already there. And if we click the add button, you'll see that it's somehow still not there for some reason. And that is because we have not reloaded the data. So keep in mind, because we are adding something to the roster, we now need to sort of fetch that data again and update it. So what we need to do here is, in this case, once we... Wait, is that on? Oh, right. This is sort of where refreshing comes in, which is what Tiffany's going to do. But keep in mind, it is actually there. We just need to sort of figure out how we're going to update that view again to sort of show it again. So if we actually go back to this, you'll see that it's actually right here. So we have successfully added that post to the backend. It's just now we have to sort of figure out how we can re-update this view to display that information now. And that's sort of what Tiffany is going to cover in the next section, where we're going to cover refreshing. Yep.
Okay, cool. Thanks, Richie. Real quickly, I know that the post request was a little more convoluted in terms of the parameters and such, but I just wanted to re-emphasize that, like, the parameter we're defining here is very similar to if you go to Postman and when you go to the body, you see how I'm basically sending it in JSON form, right? And the reason why we define this parameter is these two are basically synonymous in the sense that with Swift, you have to define the parameter like this, so you can pass these names, subteams, positions in. But in Postman, you can simply just pass in a JSON in this raw form. Okay, so back to the more important part of refreshing. So generally, if you think of an app, when you want to refresh something, the ideal motion is like this sort of swiping down motion, right? And you get that little like spinny load bar. So we're going to talk about how we can actually make that happen so that every time we refresh, we're able to fetch a new roster and have that appear actually at the bottom of our table view. So there's actually a refresh control object that Swift actually has. So you can simply define it by using the constructor, let's call it refresh control. And you can simply define it by, there you go. It's just called UI refresh control. So you can first define it like this. And then to actually use this refresh control, we have to attach it to our table view. So the way we can do that is simply by like adding it as a property of our table view. So if you see down here, right under where we register table view, you can, I guess, give some line breaks, and you can actually add it as a property. So if you do table view dot refresh control, you can see that it takes in a optional UI refresh control object. So we hit enter, we can set it to the constructor that we just used up here, which is this refresh control, right? So you can take that and put it down here. So now we have this refresh control object that basically has been attached to this table view. So every time you, I guess, scroll down, it should, I guess, reload. But before we can do that, we actually have to give this refresh control, I guess, object. We actually have to tell it like what you want it to do, right? Because when you refresh, I guess generally the idea is that you want it to like reload the data. So you can actually, the same way you would use a button, give it a target. So in this case, it's just going to be, the target is going to be self because it's going to be this view controller. And we actually have to use you remember from defining buttons, we use this like hashtag like selector function where we pass in an Objective-C. And then for this, we're going to use .value changed. So every time we basically scroll down, it'll call whatever function we pass into this hashtag selector. Does that kind of make sense? So Richie defined this for us very generously. So every time we scroll, we want this function to be called, right? And in this case, we can just pass in. Oh wait, sorry. No, we don't want to do that. We don't want to. Okay, sorry, that's my bad. So my mistake there was that like if we pass in this add new member function, we would basically call this function again every time we scroll down. But instead, we actually want to fetch members again, right? Because every time you refresh, you want to refetch all the members. So we have to turn this into an Objective-C function by just adding this little add Objective-C there, and then we can actually pass this function into the selector. So now if you, let's build it right for now and see how that looks. So just to reiterate, we created a refresh control object. We assigned it to our table view. We gave it a target so that every time we actually make that motion of scrolling down, it calls this fetch member function that makes this network request and actually fetches all the members from the backend. So if you can see, if you kind of scroll down right now, you see that it has that like sort of refreshing motion. But you'll slowly see that this doesn't go away, right? So an important idea is that we actually have to end the refresh. So if you don't, I guess, implement this, your thing will stay in an infinite loop forever, and it'll just keep trying to refresh and refresh. So how we can do that is actually by, after we reload the data, right, after we make this call, we can actually do self.refresh control, that refers to the control we were using earlier, and actually call a end refreshing function here. So if you look at the spec, it says that it tells your control that refresh operation has ended. So this kind of makes sense because after we reload this data, you can assume that your table view has been done refreshing. So now if I build it again, okay, and let's see, let me add, let's do we need 5K. Rebuild that again, just so we have a difference, so we can kind of see that difference. So if I hit this plus button, it'll perform this add new member request. So let's hit this plus button. So if you look down here, this is the one which you created earlier, right? So now if I hit refresh like this, it ends refreshing. I scroll down and you have a bunch. I guess this is the one I created. I think someone else also made a request just now, but now we have this new post request I just made. Any questions? So I was going a little fast because we're a little tight on time. Cool. So I guess that's all we have for lecture and demo for today. We should do the Kahoot, right?
Yeah.
Okay. How do you end your quick time?
Yeah, sorry for going over, guys. Today's lecture was pretty long, but let's just do the Kahoot real quick so we finish this up. And